What am I? There we go. Okay. All right. So we're going to look at infinite limits. So tomorrow we will do the horizontal asymptotes, which are defined. Remember in grade 12, you learn those rules for horizontal asymptotes. If the bottom has a bigger degree than the top, it's 0. If they have the same degrees, it's the leading coefficient. And if the top is bigger degree, you don't have a horizontal asymptote. I will explain why those rules exist tomorrow when we do limits as x goes to infinity. Okay? So that's talking about what happens way out here. What we're going to do right now is when you approach a number and the limit equals infinity. So if you look at this graph, 3 over x minus 2, nothing cancels. It has a vertical asymptote at x is equal to 2. So you would say the limit as x goes to 2 is what? Does not exist. Everybody's uncertain now. Whoa. Does not exist. But if I said, what is the limit as x goes to 2 from the negative side? Where are we going? Minus infinity, because you're coming this way, right? So that's negative infinity. The limit as x goes to 2 from the positive side, you go? Positive infinity. All right. This is the definition of a vertical asymptote. If your limit spins up to positive or negative infinity, that is a vertical asymptote. Okay? We always just say what makes the bottom 0, but the actual definition is the limit of the function goes to positive or negative infinity. Either they shoot up or they shoot down. Okay? So how do you figure these out without drawing a graph? That's what we're going to do right now. So okay. Now, before we do this, you have to accept something. What do I want to say here? A constant number divided by 0. Any constant divided by 0. Shh. What is any constant divided by 0? Okay, we say undefined. But I just told you. Yes, I just told you when you're dividing by 0, that's actually a vertical asymptote, right? And what does the graph do? By definition, as you approach a vertical asymptote, it goes to positive or negative infinity. Therefore, any constant divided by 0 is positive or negative infinity. Okay. You can test it if you take. You don't need to write this down, but if you take any constant 10, divide by smaller and smaller numbers, like 0.1, and then go 10 divided by 0.001, and then 10 divided. Oh, yeah. 0.000001. The numbers are going to spin and get super big. All right? Does that make sense? If you do it on your calculator, you'll see it. And these are getting closer to 0. Okay, so this is what we're trying to do here. I know the top is always going to be 1 for this function, right? Yeah. That's not going to change, so I'm just going to put 1. I know if I put 5 into this function, what am I going to get? 0. Okay. So this is a sort of new notation. I didn't used to do it this way, but a PhD in math showed me how to do this, and I really like it. So you know it's going to be 0. What you have to ask yourself, is it going to be a quote unquote positive 0 or negative 0? Now I know 0 is not positive or negative, but if you think about it, you're doing a limit. You're coming from 5 negative, so the negative side of 5. There's negative 5. I'm coming from, positive 5, and I'm coming from the negative side, so I'm coming this way. What would be a number that's less than 5? 4. Just go with 4. Nice, easy number. If you put 4 into here, 4 squared is what? 16. What's 16 minus 25? Negative 9. All I care about is that it's negative, right? Any number I put in there that is less than 5 will be negative. Does that make sense? So you're dividing by 0, sort of negative. A negative 0. I know it's not a negative, but just think of it that way. Because you're approaching numbers that are smaller than 5. We know 1 divided by 0 is always plus or minus infinity. Positive number divided by a negative number is a negative number. So where are we going? So this equals negative infinity. Because it's less than 5. We're coming from the negative side of 5. And 5 is the vertical asymptote, right? It's going to go to negative infinity. That's what it's saying. If we come from, well, let's just do the other side. If we come at 5 from the positive side, the top is always 1. The bottom's going to be 0. But what's a number bigger than 5? 6. If I put 6 in here, what's 6 squared? Minus 25 is 9. Okay, but positive is what really matters here. So then it's a positive divided by a positive is positive. So you're going to positive infinity. And if you look at the graph of this function, it has asymptotes at negative 5 and 5. And it looks like this. Which one? Because if I put a number that's bigger than 5, so I'm coming at 5 from the positive side. Sorry? Yeah, like you're coming from the right side of it. Oh. Right? So you look at it. Here's 5. If we come at it from the positive side, where does the graph go? It goes to positive infinity. If we come at 5 from the negative side, it goes to negative infinity. Okay? All right. One more, and then we're done. This is a way to evaluate one-sided limits without doing a whole bunch of work. I don't want to sketch that graph. I just want to know what is the value of the limit. So let's do the top one. So it has a discontinuity at 1. Does everybody agree with that? Okay. If we come at 1 from the negative side, so numbers that are smaller than 1, there's 1. What's a number that's smaller than 1? 0. Okay. If you put 0 into this, what do you get? Negative, right? You got 1 over a negative, quote unquote, negative 0. So it's going to be negative infinity. What's a number bigger than 1? It's going to be 2. What are you going to get? It's going to be positive. The top's always positive. Can we all agree on that? Because you're adding everything together, and we're looking at a positive number here. So it's always going to be positive. So you don't even have to worry about the top. The bottom depends on what you're doing. So number bigger than 1, and then you cube it. That's still going to be bigger than 1, even though you're subtracting it. So it goes to positive infinity. And if you look at the graph, it looks like this. And that's x is equal to 1. Okay? It's a way to evaluate one-sided limits without sketching the graphs. In this case, right? Because I'm squaring it, and then I'm adding it, and then I'm adding. I'm always adding. If you start to subtract, then you got to look at things. But if you're always adding, it'll be positive. Okay. Page 88, 5, 7, 29, 31, 33 to 43, odd, 65 to 71. They're just one-sided limits, people. Test is on, what did I say test? Thursday.